Okay, we're doing a pre-lab, which is for measurement pre-lab. That's lab book exercise 2. What we're going to do today is just go through a few items on what you'll need to know in order to accomplish this lab. We're not going to do the lab for you. Obviously, that's something you need to read through and be prepared for before you ever come to lab. As well as read this recording. We're going to just make sure you understand how to use this. Got a meter stick here. That's what you're looking at, and we'll use a balance beam. It's a triple beam balance. Obviously, they do make the electronic balances, which we do have some, but we do require students to know how to use a triple beam balance. We'll go through that, and then we'll also show you how to correctly read a graduated cylinder. And those are the 3 things that we feel like we need to accomplish in order for you to be successful with this lab before you ever walk in. And obviously, if you do have questions, then we're certainly available, and we'll be more than happy to help you with those questions. Okay, so let's work with this metric, this meter stick. I was going to say metric ruler, but let's just play with this a little bit. As you can see, we have got a 50, so we're looking at 50 centimeters distance on this meter stick. Of course, the entire meter stick would be 100 centimeters is what you would have. We're just on the 50 yard line right here. That's where we're looking at, if I can get on it. All right. So that's 50, this is 51 centimeters, 52 centimeters, and it's going to be a little difficult, but if you were to count the spaces, not the lines, but if you were to count the spaces between the 2 and the 3, you would actually find that there are 10 spaces. Well, those spaces represent millimeters. So if I were to put, let's say, this little ruler on 51 centimeters, I'd be sitting right there, and if I were to put it on the second line, you will have 2 spaces after the 1. So, and that's not, there we go. Try to get that to look correct. And then you have 51 centimeters and 2 millimeters, or you would say 51.2 centimeters at that point. All right. So let's then take it. Let's go from 50, which I'll try to get this on that 50. And let's go to 65. Okay, and if I can get that lined up just right. All right. You may call me a moron. That's fine. It's pretty difficult, but if we were to put it on the 50 and then line that up with the 65, then of course from 50 to 60, that would be a total of 10 centimeters, and then I've got 5 more centimeters, so that would be a total of the 10 from the 50 to the 60. Here we go. And then if I were to go to the 5, then that would be 65 centimeters. Well, what if I put it on again? Let's put it on the 2, the second line. That's the first line, I think. And then maybe that's the second line right there. Okay, so we're looking at 50, and then that's 55 centimeters, and then we have 2 millimeters. So you're looking at 15.2 millimeters at that point, 15.2. So it's very important that you need to be able to use one of these. Most likely, you will also be using these in the on the lecture. I mean, lab test. You'll have to be able to do this. So be sure that you do not have questions, or if you wanted to read this, and if maybe the question asks, okay, what if give me an answer in millimeters instead of centimeters? Well, okay, you might want to start back here, and you got 10 millimeters between the 50 and the 51, and then between the 1 and the 2 you have 10 more. So between the 50 and the 2, that gives you 20 millimeters. 10 between the 50 and the 51, 10 more between the 1 and the 2, 10 more between the, between the 50 and the 3, that's 30. Between the 50 and the 4 is 40, 50, 60, 70, 80, 90. Of course, there would be 100 millimeters right there between the 50 and the 60. And then I forget where we were, but I think we were on the 5. That's where we were, I remember. Okay, so we're looking at 150 if we're on the 5. But then if I put this on the 2, the second line, okay, we're at 152 millimeters. Okay, so you're not going to be exactly sure whether on the exam we're going to ask possibly to measure something in centimeters or in millimeters, and hopefully that will help. If you do have problems with that, then certainly we do have lab time, and we will be able to help you with that. One more time, be sure that you've read that lab before you come in, as well as listen to this pre-lab. And I think when you get here, then hopefully you will not have problems with that. Okay, so let's move that meter stick, and let's go to, let's see what we can do with a, from there we're going to learn how to use your triple beam balance. If I can turn this thing around, maybe you can see it better this way. Okay, let's I'll pause that. Okay, here we go. All right, this is a triple beam balance. Okay, let's pause this. Okay, well, all right, so what we're looking at here is a device. You've got a pan where you would place an object, and then you can see that you have 3 bars, and on those bars you have numbers, and the top bar measures in grams, measures an object like it will only move, and there'll be a groove where it will be stationary. That measured 10 grams, this measured 20 grams, 30 grams, 40 grams, and so forth. The middle bar will measure in 100 grams, so we can go from 0 grams to 100, and you'll feel it when it actually lands in that groove, and you go to 200 to 300 and so forth. Okay, and then the bottom is a slider, and there are no notches there, so you won't feel it when you go from let's say from 0 to 1 gram. Well, okay, we can move it 1 gram, so at this point we've moved it exactly 1 gram. All right. Okay, then we can move it 2 and 3 and so forth. But what if we didn't want to move it just 1 gram? What if we wanted to move it, say, a half a gram? And this will be somewhat difficult for you guys to see. But let's see if I can get this where you can see that. That is actually on half a gram right there. Again, when you come to lab, you will have an opportunity to grab a hold of one of these yourself, and if you have trouble, we'll be more than happy to help you. Well, that's a 1/2 of a gram, which is 0.5 gram. I could go to 0.6 gram. I could go to 0.7, 0.8, 0.9. I could go to 1 gram, 1.1, 1.2, 1.3, 1.4, 1.5 grams. All right, so that's how you would measure. Now what we need to do then is place something on this pan. Let's say that we have my keys, and there you go, keys. So let's take a measurement on that and see what we get out of it. All right, so let's pull this thing over. I want you to see what we're doing now. All right, so we're going to take that, and we want this to balance out. Okay, so at this end, you will see that this moves, and there is a space at which it is totally balanced, and a line that you should be able to read that will say 0 right there. And when it's totally balanced, it will balance at that 0. Okay, so we'll put something directly on that, and we're doing this at an angle, so we're at a bit of a disadvantage. You won't be at that disadvantage, but I'm a very clever individual. I believe I can handle this. Now, don't try this at home. You could hurt yourself. I don't want anybody to be hurt. So I'm going to start with the top rider, and let's, I have no idea what that weighs. In fact, and let's see what we've got. All right, let's see what we've got. Okay, we're going to try this again. Don't leave us. Don't leave us. Stay there. All right, so I'm trying to get this thing to balance. I'm on 30 grams at the moment. I'm on 40 grams at the moment, and look, we're getting pretty close because I slowed down. Now, if I get on 50, it is below the 0 line that we showed. All right, I'm going to back up to 40, and it's going to go above the 0 line. All right, now you can't see the 0 line. I can, but if I move, I'm afraid I can lose my keys. But I'll show it to you anyway. Okay, I'm above the 0 line. There we go. So let's go back now. So it's 40, and I know it's going to be a little bit more than 40, so I don't even want to mess with that 100 gram weight. I'm going to go to 41. Let's mess with that. Let's see if it balances out. I'm going to go to 48, 47. I'm getting pretty close right there. All right, I'm on 42, and it is not exactly on the 0, but okay. I'm on 42.2. And if we can get this over here, you'll see that this is pretty well balanced on the 0 line. There we go. It is not perfect, but yours should be perfect. I didn't do it perfectly, but I've already passed this class. We're not worried about my grade. We're worried about your grade. You need to get that perfect, because whatever it is you're going to measure on the lab test, we've already measured, and we know exactly what that number will be. And if you don't come up with that exact same number, you miss that entire question. And I can promise you, at the end of the semester, you're going to want some points. So pick up every one you can get. That's just one that you're going to want. Okay. Now, the next thing we're going to do is we're showing you an object. This is called a graduated cylinder. Now, I'm going to lie this thing down because we are at a bit of a disadvantage. Okay, so let's see if we can get this. Let's see, where it's more easily seen. And that's not helping us a whole lot. Maybe if we do it this way, that won't help us a whole lot either. Okay. Let's maybe if we enlarge this puppy, make the puppy a little bigger, see if that helps us. Okay. What I'm wanting you to see, these have numbers. That's why they call them graduated. The other thing I'll point out is anything that has lines on it, this glassware, it's expensive. If you drop one of these things and break it, no one will be upset with you. You do pay a lab fee, but if it has lines on it, it is relatively expensive. It's going to cost money. I don't know what this thing would cost. I haven't ordered any in a number of years. But if it doesn't have lines on it, those are not expensive. So we don't worry too much about that. But if you break something, you just do. Everybody makes mistakes, and I certainly make more than most. Now, I don't know if you can read this at all, but this says a 50 at this point right here. That says a 50. This says 45. Okay, and these are in milliliters. And this will be 40. This right here will be 35. This would be 30. Okay, so let's just pretend that I have filled this thing up with water or whatever solution we're wanting to use, and I filled it all the way up to, now this is 40. You may not be able to read that, and I'm very sorry for that. And then it will go 42, 44, 46, 48. Oh no, I'm sorry. 41, 42, 43, 44, 45. And then 45, 46, 47, 48, 49, and 50. Okay, so it's going to be really difficult for you to read. This is 45, and if I were to go up 2 lines, I am at 47. I started at 45, I went up 2 lines, I am at 47 milliliters. Okay, one other thing you do need to know about this graduated cylinder, if we can get down to the base of it, and I will guarantee this is very difficult for you to see, and I do understand that. So you certainly are at a disadvantage, and my apologies for that. But again, you've got time in lab to work with this, and we will help you with it, and we'll make sure that you totally understand, and we'll have no problem using one of these. So don't be concerned with that if you're not being able to see what you feel like you need to be able to see. We will get that accomplished for you. But from the very base of this to the very first line, that is actually 2 milliliters. It is 2 milliliters. Okay, so if you go from the base to the first line, you've already covered 2 milliliters. And then you've got one more, which is 3. The next one is 4, and then this line right here would be 5 milliliters. And a lot of people don't understand. They think if you fill to the very first line, you have filled 1 milliliter. You would be wrong. That's 2 milliliters, and that's very important to know, particularly if you're measuring a very small volume. So remember that from the beginning to the very first line is 2 mils, 2 milliliters, and sometimes we just abbreviate that. We just call it mils at that point. Okay, so this is the graduated cylinder, and if you notice, it also has a plastic ring at the top of it. The reason that plastic ring is there is because if it were to fall over, which sometimes they do, then it's not going to break. If that plastic ring were pushed further down, or possibly all the way to the base, and we were to drop that, then yes, we're going to break that top off. And it's like I said, this equipment is somewhat expensive if it is graduated, so we want to not make that mistake and try to conserve the equipment. The equipment, of course, is paid for by tuition, but if you think by any stretch that your tuition pays for everything around you in this room, and the air conditioning and the instructors and the cleaning people and what it takes to run a school of this magnitude, you would be very wrong in that thought. A good majority, or I would say the majority of, well, part of it comes from your tuition, part of it comes from state funding, and also, which means taxes, and also a good part of it comes from property taxes, which, you know, I have property here in Ector County, so I do pay property taxes. And so the way I see this personally is that graduated cylinder belongs to me personally. I have paid for that. In fact, I've paid for many graduated cylinders over time. I've bought many of those. So if you break it, it's like, oh my goodness, we're going to have to buy more of those, and they may raise my taxes if too much of that happens. So I hope you do understand where the money comes from in order to support your education. Okay, enough of the soapbox. I'll get off that one, and good luck. I hope this helps. I know it's not been a perfect pre-lab, but we are under some constraints. There are some issues here that we need to try to resolve, and we will try to resolve those as quickly as possible. Again, certainly we'll be able to help you, and you will be able to be successful with this lab. All right, thanks.